Hello dear students, and welcome to this video presentation where we'll be looking at 2024 GCE proposed solutions for pure mathematics with statistics paper 2 as well as pure mathematics with mechanics paper 2. Given that this GCE session, both the mechanics and statistics students wrote exactly the same question paper. I doing the presentation, I'm Tata Ernest, and in this presentation we are going to look at all the 10 questions that came in this session. So the presentation will be quite long, so to this effect I'll be leaving timestamps in the video's description. So if you are watching this video on YouTube, then just go to the video description. You'll be able to see timestamps which are tied to each question in this presentation, and if you click on that timestamp, it will take you to that particular question where you have difficulties or where you want to know how that question was supposed to be solved. And also, in the course of this presentation, if you would like to get this presentation as a PDF or a handout so that you can always go through the presentation and then try to solve the questions, then you are going to check the first comment section, and it will redirect you on how you are going to join a forum where you'll be able to get this PDF or this presentation as a PDF, as a handout. Then in the course of watching this video, if you find this video useful, then please give me a like on this video, subscribe to my channel, and turn on the bell icon so that each time I post videos like this one, you'll be among the first person to receive it. And also, you can share my videos to those whom you think this video can be useful to them. Thank you so much for your kind attention, and we are going to begin right away with question 1. Now let's begin with question 1, a question on functions and quadratic equation. Question 1, Roman 1. Express 4x plus 3 divided by 2x minus 1 into 3x plus 1. X belongs to the set of real numbers, x different from negative 1/3 half in partial fractions. So in this question, we are required to express this expression into partial fractions. Now our goal here is to look at the denominator and split these two linear factors into two separate factors. Now, when you look at the denominator, you are going to realize that these two factors in the denominator are linear. Linear because the highest power to which x is raised to here is 1. So we are going to split this expression into two linear terms by placing a constant on their numerator. If these expressions below here were not linear like this, it wouldn't have been possible for us to split and place a constant on their numerators. So what we have to do here, it is now to be able to use our knowledge in mathematics to obtain values of a and b. And also you have to take note here because I've used an equivalent sign instead of the equal sign here, because using an equal sign means that the left hand side and the right hand side of the equation are exactly the same in value and in any variable in that expression. But using an equivalent sign this way give us the flexibility to be able to manipulate these expressions and obtain values of a and b. Now there are many ways by which you can proceed to find values of a and b, but in this particular exercise I'll start off with the cover-up method. The cover-up method is a method which is relatively easier and straightforward because you can directly have the values of a and b without doing a lot. So I'll apply the cover-up method. So how do I find a? I will identify the bottom denominator of a, which is 2x minus 1. I find its critical value. I return back to this expression that was given to me, cover up 2x minus 1, and substitute that critical value everywhere else I see x into that expression. Alright, let's put that into practice. So if I take 2x minus 1 and equate to 0 and I solve for x, x will give me half. So I'll return back to this expression given to me, I'll cover up 2x minus 1 and I'll substitute half everywhere else I see x. So a will be equals to 4 into half. I add now the 3 that I have here, divided by, remember I had covered this other factor here, so into 3 into half plus 1. So if you evaluate all of these, it's going to give you 2. But let us take our calculators and let me show you how easy it is to evaluate. Using the calculator is a very essential skill in the GCE, and I'll be showing you how you can evaluate this. To evaluate this expression to have 2, I'm going to solve the numerator separately, the denominator separately, and divide them. So on my calculator, I'll open 2 brackets. So open the first bracket divided by the second bracket. Then I move now within the first bracket. I will then put in everything I have here on the numerator. So I'm having 4 into half, 4 into half, and half can be written as 1 divided by 2. I close the bracket, I add the 3 that I have there, and I move on to the second set of brackets, and I have 3 into half. Half again is 1 divided by 2. I move on, I close the bracket, and I add 1 to that. Now I have plugged in everything exactly as it is on the question. Now if I hit the equal sign, you see that it gives me 2. So knowing this skill in the GCE is very essential because it saves you a lot of time and avoids making silly errors. Alright, with that being said, let us return back to the main presentation, and then you are going to have A as 2. In the same way, to obtain B, I will identify the button of B. Then I take this button of B, I find the critical value. So 3x plus 1 is equal to 0. X will give me negative 1/3. So I'll come here and I'll cover up this 3x plus 1, and I'll substitute negative 1/3 everywhere else I see x. That is why I have 4 into negative 1/3. I add now the 3 I have here divided by 2 into negative 1/3 minus 1. Evaluating in the same way as we did for A will give us B as negative 1. So decomposing this expression into its sum or difference of its partial fractions, you are going to have this expression on the right hand side. I hope you have understood. Now, what else do you need to know in order to apply the cover up method? This method is convenient to use when the denominator of the terms to be split is linear. So if the denominator is quadratic or something else, then the cover up method will not always work. In fact, sometimes it becomes impossible to use it in order to proceed. So you can use other methods like this method here, where you are going to start by finding the LCM. The LCM will just be the product of these two factors because they don't have any common factor. Then when I take this LCM and I divide by 2x minus 1, I have now this 3x plus 1 multiplied by a, I have a into 3x plus 1. Then taking this again and dividing it by 3x plus 1, I'll obtain 2x minus 1 multiplied by b, I have b into 2x minus 1. Now at this juncture, I'll realize that the fraction or the expression on the left hand side and the expression on the right hand side both share the same denominator. So if I multiply both sides by this common denominator, then it's going to strike off from both sides of the equation. Multiplying, I'll just have this is equivalent to a into 3x plus 1, then plus b into 2x minus 1. Then at this point, I will just multiply out the bracket on the right hand side. A distributes into the bracket, b distributes into the bracket, and I have this 3ax plus a, then plus 2bx minus b. These two terms are terms in x. I can bring them together by factoring out x. I have x now into 3a plus 2b, then plus a minus b. At this point, if the left hand side is equivalent to the right hand side, it means that the corresponding coefficients are equal. So I can now equate them and in order to find values of a and b. So notice that the coefficient of x on the left hand side is 4, and the coefficient of x on the right hand side is 3a plus 2b. So I can equate them. And also the constant term on the left hand side is 3, while the constant term on the right hand side is a minus b. So I can have these two equations, which is 3a plus 2b plus 2b, here is b, is equal to 4, and a minus b is equal to 3. Now, I'll assume that you can solve this simultaneous equation because here it's supposed to be b, it's just a typing error here. And if you solve this simultaneous equation, you are going to obtain that a is equals to 2 and b is equals to -1. So you are going to be having the same answer that we have here. So I hope you have understood. Now, if you are watching this video and you like the content, then I will really like, or I really appreciate if you give me a like to this video, subscribe to my channel, and turn on the bell icon to receive videos like this one in the future. And also, let us move on to the second part of that question 1. The second part on that question 1 is a question on quadratic equations. And the question reads, if the root of the quadratic equation x squared plus k plus 1 into x plus k equals to 0 are alpha and beta, find the values of the real constant k for which alpha is equal to 2 beta. We have been given a quadratic equation, and we have been told that the roots are alpha and beta, and also that alpha is equal to 2 beta. Then we have been asked to use this knowledge given in the question to obtain the value of k. Now, the first thing to do is that this question is based on the relationship between the coefficients of a quadratic equation and its root. And we know that if we sum the root of a quadratic equation, it's going to give us -b divided by a, where b is the coefficient of x and a is the coefficient of x squared. So the sum of roots alpha plus beta is -b. b is whatever multiplies x, divided by a is whatever multiplies x squared or the coefficient of x squared, which is 1. So dividing -k plus 1 by 1 leaves me with the same expression. But I was told that alpha was 2 beta, so I can replace alpha here with 2 beta, and I'm going to have 2 beta plus beta equals to -k plus 1. That gives me a 3 beta is equals to negative into k plus 1, dividing both sides by 3. Beta gives me this expression here. So let me call that equation 1. I need also to use the idea of product of roots, where alpha times beta gives me c divided by a, and c is a constant term k, while a of course is 1. So k divided by 1, 1. But alpha is 2 beta, so I have 2 beta into beta equals to k. Multiplying out the bracket, I have 2 beta squared equals to k. So making beta squared the subject, beta squared is equals to k over 2. Let me call this equation 2. So I have equation 1 with 2 unknowns, beta and k. I have equation 2 with 2 unknowns, beta and k. So this is a simultaneous equation, which is not linear because one is quadratic, where we have to obtain the values of k. It becomes very easy because in equation 1, I had already made beta the subject. So if I take beta and I substitute into equation 2, then beta will vanish and I'll be able to find the value of k. So let me do that. So I'll be having -k plus 1 order squared divided by 3 squared that I have here. Yeah, so I have that is equals to k divided by 2. Multiplying out the bracket or expanding the numerator, I'll have k squared plus 2k plus 1, and 3 squared gives me 9 is equals to k divided by 2. Now at this point, I can just cross multiply in order to have an equation which I can solve. So when I cross multiply, 2 multiplies with each term of this numerator and gives me 2k squared plus 4k plus 2, and 9 multiplies with k and gives me 9k. So bringing terms together, because this is a quadratic equation in k, I have 2k squared, 4k minus 9k negative 5k plus 2 is equal to 0. Now at this point, I have now to split this middle term into 2 convenient values in order to group and factorize. Now when I multiply 2 times 2, I get 4. So I'm looking for 2 numbers, which when I multiply them, I get 2 times 2, which is 4. And when I add them, I get -5. And those numbers are nothing but -1 and -4. So I have split this -5. I can now group them and factorize. K is common to the first 2 terms. So k into 2k minus 1. and negative 2 is common to these two last terms. So negative 2 is factored out into 2k minus 1. Then 2k minus 1 is common, because if you choose these factors rightly, you always have common factors to factorize again. So finally, I have k minus 2 into 2k minus 1 is equal to 0. And from this juncture in mathematics, if I'm multiplying two terms and my result is 0, it means that either the first is 0 or the second is 0, or both of them are 0. So equating each arm to 0 and finding for k, I'll have that k is negative 2 or k is equal to positive half. Now in solving this question, what is the idea, or what are the skills we are supposed to learn? The first skill is that the following relationship between the coefficients of a quadratic equation and its roots are very important. In a quadratic equation, ax squared plus bx plus c is equal to 0. If the roots are alpha and beta, then the sum of the root of the quadratic equation, alpha plus beta, is equal to negative b divided by a, and the product of the root of the quadratic equation is given by alpha times beta, which is equal to c over a. I hope you have understood, but if you do have any questions, please leave it down there in the comment section. I'll make sure to read them and answer them to the best of my knowledge. And if you are watching this tutorial and you want to have this presentation as a handout, a PDF that you can always go through and read, then make sure to check the comment section. I'm going to give you a method, or I'm going to enlighten you how you are going to join a WhatsApp forum in order to acquire this presentation as a handout. Thanks a lot, and we are going to move on to the next question. Alright, question 2 is a question on polynomials, and the question reads, the first part of question 2 is the polynomial f of x, where f of x is equals to ax cubed minus x squared plus bx plus 6 has factor x plus 2. F of x leaves a remainder 10 when divided by x plus 1. Find a, the values of the constants a and b. Then we have an expression f of x is equals to this, and the factor of that polynomial is x plus 2. A factor here simply means that if I divide f of x by x plus 2, I will have no remainder. It will divide it exactly without any remainder. And so we have also been told that when this function is divided by x plus 1, it will leave a remainder of 10. Let's use these two ideas and find the value of a and b. So I'm going to use the idea of a factor. So if x plus 2 is a factor, then I have to find the critical value of x plus 2 by equating x plus 2 to 0 and finding x, where x will give me negative 2. Then if I plug negative 2 back into this expression, my answer should give me 0 to tell me that the remainder is 0. So I'm going to proceed by substituting negative 2 into this expression. So f of negative 2 should be equal to 0, because I'm certain that x plus 2 is a factor from the question. So substituting it, I'll have a into negative 2 cubed minus negative 2 squared, then plus b into negative 2 plus 6 equals to 0. Then I just have to multiply out the bracket. Negative 2 cubed gives me negative 8 times a, negative 8a, negative 2 squared 4 times negative 1, negative 4, b times negative 2 gives me negative 2b plus 6 equals to 0. I just have to bring like terms together, so I'll allow the variable, the terms in a and b on the left hand side, and I'll take the constant terms to the right hand side. So I have negative 8a minus 2b will be on the left hand side, negative 4 plus 6 gives me positive 2, and when I send it to the other side, it becomes negative 2. So I have the equation negative 8a minus 2b equals to negative 2. I could leave it like this, but I will realize that 2 is a factor. In fact, negative 2 is common to each term, so I can divide each term by negative 2, and I'll be having positive 4, a plus b is equal to positive 1. I can call this equation 1. I'll move again. I'll use the idea that the remainder when this polynomial is divided by x plus 1 is equal to 10. So I'm going to be applying the remainder theorem to this particular question. So I'll therefore have that f of x leaves a remainder of 10 when divided by x plus 1. So I'm going to take this as well, equate to 0, and find the value of x, which should give me 1. Therefore, f of 1 should give me that remainder, which is 10. So f of negative 1, I mean to say, since when I equate this to 0, I solve, I have negative 1, will give me that remainder, which is 10. Let me go ahead and I substitute negative 1 everywhere else. I see x here. So I'll have a into negative 1 cubed minus negative 1 squared plus b into negative 1 plus 6 equals to 10. Then opening out the brackets, I'll have negative a minus 1 minus b plus 6 equals to 10. Then I'll allow the terms in a and b on the left hand side. So I have negative a minus b. Then negative 1 plus 6 gives me positive 5. When it goes the other way, I have 10 minus 5, which is 5. Now, if I add equation 1 with equation 2, I will see that the terms in b will vanish, since they have the same coefficients but opposite, the same coefficient which are opposite. So adding them together, I have 4a minus a gives me 3a, and then b plus negative b gives me 0, 1 plus 5 gives me 6. So 3a equals to 6, dividing both sides by 3, a is equals to 2. So I have the value of a as 2. Then if I take a and I refer it to equation 1, I can make b the subject, as b will be 1 minus 4a, and I substitute a as 1. So 1 minus 4 into 2, simplify this or evaluating this gives me b as negative 7. Hence, f of x is 2x cubed minus x squared minus 7x plus 6. So I have obtained the values of a and b, and I have this. So if you do have any questions or if you do have any doubt, then please, I will be able to check the comment section. Just write it there. I'll check the comment section and respond to your questions. Now, let us move on to the b part of that question, which is a continuation of the a part, which says, let's find the value of x for which f of x is equals to 0. So we have to solve this equation completely. So how do we solve this equation completely? To solve it, we have to factorize f of x completely and then equate it to 0 and solve for the value of x, since it's very easy that way. So to do that, I have to start by performing long division. So I'll be dividing f of x, which I already have the value of a and b, by that factor, which is x plus 2. And performing long division, I'm going to be having this. So if you have a problem on how to perform long division, then just comment down there. I will make a separate video on how you can perform long division. So I've assumed that from your knowledge in O levels, you can perform long division on polynomials. Alright, so performing the long division, you are going to have the quotient or the answer as 2x squared minus 5x plus 3. And the remainder will be 0, of course. And now, I can now write f of x as a product of the divisor and the quotient. So f of x will be equals to x plus 2 into this quotient that I have here. Now, this quotient is quadratic, and I can go ahead again and I factorize it. So I'll be looking for two numbers, which when I multiply, I have the product of 2 and 3, which is 6. And when I add them, I will have negative 5. And those two numbers are nothing than negative 3 and negative 2. So I will split this negative 5 into those two numbers. So I'll be having 2x squared minus 3x minus 2x minus 3x minus 2x plus 3. Now I'll group these two terms and factorize them. I'll be having x into 2x minus 3 minus 1. I factor out negative 1 here, 2x minus 3. I said in the previous question that if the expression can be factorized and you choose the right factors well, you always have similar factors here to factorize again. So 2x minus 3 is common. I can factor out it and I'll be having x minus 1. So I have factorized f of x completely. So f of x is equal to this expression. If I multiply out the bracket, I should come back to f of x, which I have here. So I will just equate it to 0 and then use the null factor law to obtain the value of x. Equating it to 0 means x plus 2 is equal to 0, which should give me x as 2, or 2x minus 3 is equal to 0, which should give me x as 3 over 2, or x minus 1 equals to 0, which should give me x as 1. So we have come to the end of the presentation for question 2. Hope you have understood what I have explained. But if you do have any questions, then leave it in the comment section below. And remember that if you want the detailed solution as a PDF, then check the first comment. I will direct you on how you can get this presentation as a PDF handout. And also, do not forget to give me a like on this video, subscribe to my channel, and turn on the bell icon so that you will be amongst the first persons to receive videos from this channel. Thank you so much, and we are going to move on to the third question. Now with question 3, linear relationship between two variables. The question reads, the table below shows approximate values of a variable y corresponding to certain values of another variable x. So these are values for the variable x, and these are values for the variable y. By drawing a suitable linear graph, verify that these values of x and y satisfies approximately a relationship of the form y is equals to ab raised to the power x. Using your graph, find approximate values of the constants a and b, giving your answers to 2 decimal places. So we have a table showing values of x and values of y, and we have an equation that gives us the relationship between the values x and y. And we have been asked now to use these values of x and y together with this equation, draw a suitable straight line graph where we'll be able to find the values of a and b. Now, to answer that question, you are going to begin with the equation y is equals to ab raised to the power x. So what we have to do is that we have to write this equation in the form of the equation of a straight line. The standard equation of a straight line is in the form y is equals to mx plus c, where y and x are the general point, m the gradient, and c the intercept with the y-axis. So, and in order to obtain that from this expression, we have to separate the terms on the right hand side into 2 other terms. This can be done mathematically by either using log or ln. So in this case, I'll use log, even though if you use ln, you are going to arrive at the same answer. So I'm going to take log on both sides of the equation. And taking log on both sides of the equation will mean that log y is equals to log a, then plus x log b. I can just reorder it to have log y as x log b is equal to have log y to be x log b plus log a. So in this case now, I'm going to be plotting a graph of log y on the y-axis against the variable x on the x-axis, and then the gradient of that line will be log b, and the intercept, or where that line will cut the y-axis, will be log a. So it's very important you know the variables and what you are looking for and the constants from this question. Now, let us look at the table again. This is a table. These are values of x. These are values of y. Then I have to plot a graph of log y against x. That means I have to use these values and manipulate them to obtain the values of log y. So for each value of y, I will punch log y to obtain its corresponding value. So let me go to my calculator and then take some few values of y and evaluate the value of log y so that you can confirm that these are the values that I have. Let me start with 3.47 and evaluate log 3.47, and that gives us 0.54. Notice that I've left my answers to 2 decimal places because that is a precision given in the question. So let me take the next log, which is log 5.50. So I have log 5.50. So that gives me 0.74, what I have here. So you continue in the same manner to obtain the rest of the values of log y. Now, notice that below here, I have written these values more nicely. I have shifted this decimal point 1 place to the right by multiplying by 10. So I have multiplied each of these values by 10 so that I can have convenient values that I can easily plot them on the graph. Because I have multiplied by 10, I have to indicate that I have multiplied by 10, so I divide the values here by 10 to come back to the initial value of log y. So this skill is very important because it makes you to easily draw your graph without having to bother much about choosing a complicated scale. So now that I have rearranged my value and I'll be plotting a graph of log y times 10 to the negative 1 against x. Now let us come to our graph. This is a graph that I plotted already. I'm sure you can see, but I will surely zoom in so that you can see it well. These are the values that I'll plot on the y-axis. Log y times 10 raised to the power negative 1, and then I'm plotting it against x. Now these are my axes, very important. After the axis, I have to choose a scale. Let me start with the x scale, the scale along the x-axis. In the question, the values of x start from 10 right up to 80. So I have to choose a good scale that my graph will occupy at least 3/4 of the graph paper. So, and the best scale that I can choose here is by choosing 2 centimeters for 10. Because if I take 2 centimeters for 10, then I'll be able to indicate the values right up to 80. And when you choose your scale, the next thing you have to look for is the precision. The precision here means what is the least value of x that I can plot. And the precision is obtained by taking the scale and dividing it by the number of subdivisions that you have. For instance, I have 10, and from this point to this point is 10, and within those points I have 10 subdivisions. So my precision will be 10 divided by 10, which is 1. So the least value that I can plot along the x-axis is 1. Now, what about the scale on the y-axis? Now, on the y-axis, I'm plotting values beginning from 5.4 to 19. And I have noticed that if I take a scale of 1 centimeter to 1 unit, I'll be able to plot the graph right up to 19. And now I also need to find the precision of the y-axis. And the precision means I'll take the scale, which is 1, and I divide it by 5 because 1 divided by 5 subdivisions will give me 0.2. So the least value or the smallest value I can plot on the y-axis is 0.2, or the value of this subdivision here is 0.2, but along the x-axis that gives me just 1. So let me go ahead and plot some random points so that you can see how to plot them. Now, when x is 10, the value of y of log y, since this is what I'm plotting, is 5.4. So on the graph, when x is 10, this is the line where x is 10, y is 5.4. So the precision on the y-axis was 0.2. So this is 5.2, 5.4. So it's supposed to be plotted here. I just move one subdivision ahead, which is not right. It's supposed to be plotted down here. Now the next point to be plotted is when x is 20, y is 7.4. X is 20, y is 7.4. So I move 2 subdivisions above 7, 7.2, 7.4. That is it. So the next one will be x is 35, y is 10.2. So x is 35, 35 should be here, y is 10.2. So 10.2, just one subdivisions above 10. So, and the next one will be y is 50, x is 50, y is 13.2. So x is 50, y is 13.2. So you are going to do that right to the end. And you are going to realize that not all the points will fall on the line. This is where the skill of drawing a line of best fit becomes very important. The line of best fit is that line that separates equal number of points above the line as they are below the line. Not all the points must fall on the line because in collecting the values, the person must have encountered random or systematic errors, and with all those errors that the person must have encountered, then it's not really possible that all the points can fall on the same line. So I have plotted, and you draw a line of best fit. Notice that I have 2 points above the line and I have 2 points below the line. So I've balanced up the line in a way that it will separate equal points above as they are below. Now at this point, what I have to look for now is the gradient or the slope. And to look for a slope, you just have to draw a big right angle triangle and identify 2 points on the line where it touches it. So this is my right angle triangle, and I identify this point and this point. And the coordinate of this point is x, is 65 and y is 16.4. While here x is 20 and y is 7. So I'll move on now to find the gradient. I know that from the graph, the log b is equal to the slope. And now the slope is change in y over change in x. So if I come back to my graph, the change in y will be 16.4 minus 7. But I have to maintain that exponent that I had used. So 16.4 minus 7 times 10 raised to the power negative 1 divided by change in x. So the change in x will just be 65 minus 20. There's no exponent to bother about, so I just have 65 minus 20. And evaluating this gives me 0.2. So log b is equals to 0.2. Now to obtain b, I need to convert this from logarithm to indices. Remember, log b means that the base to which the log is base 10. So to convert that, I'll have that b will be equals to the base 10 raised to the power of the number 0.02. So log b will be 10 raised to the power 0.02. So let me take my calculator and try to evaluate that. So I'll have that I am evaluating log 10. I'm evaluating 10 raised to the power 0.02. So that is 10 raised to the power 0.02. So that gives me 1.04 to 2 decimal places to give me 1.05. So the value of b is equals to 1.05. In the same way, the intercept is equals to log a. So the graph cut the intercept at the point where y is 3. So this is the intercept here. So I will say, so the intercept is log a is 3 times 10 raised to the power negative 1, as I've explained before. And so that means a will be equals to 10 raised to the power 0.3. And if you punch that on your calculator, it will give you a value of 2.19 to 2 decimal places. So this is the value of a. I've had the value of a and the value of b. So the skills that you need to know in this particular question is that the standard form of the equation of a straight line is in the form y is equals to mx plus c, where y and x are the points, the general points on the line. Then m is a gradient and c is the intercept. And also the gradient of a line segment is given by change in y divided by change in x. And now finally, the y-intercept is a point on the y-axis where it cuts it. Like in this case, we have the y-intercept as 3. So I hope you have understood. And if you do have any questions, leave it in the comment section below. And then also, if you want to have this handout as a PDF presentation, then just check the first comment in this video. I will explain how you can get this presentation as a PDF or as a handout. And please, if you find this video useful, then don't forget to give me a like on this video, subscribe to my channel, and turn on the bell icon so that each time I post videos like this one, you'll be amongst the first persons to be notified. Thank you so much, and we are going to move on to question 4 of our presentation. Now, question 4 is a question on sequences and series and binomial expansion. Question 4, Roman 1, on sequences and series. The first and the last terms of the arithmetic progression are 7 and 43 respectively. The sum of the terms of the progression is 250. Find the number of terms and the common difference of that progression. So in this question, we have been told that the first and the last terms are 7 and 43. The sum of the terms in that arithmetic progression is 250. Let's find the number of terms as well as the common difference in that particular progression. Now, these are the information from the question, and we are going to use a formula that tells us that the sum of the first n term in an arithmetic progression is equals to n divided by 2 into a plus l. N here stands for the number of terms in that progression. A is the first term while L is the last term, and all the information has been given. So I will substitute in this information into this formula. So Sn becomes 250 is equals to n divided by 2 into 7 plus 43. Now at this point, you can use any algebraic method to obtain a value of n, but for me, I'll find it easier to multiply both sides by 2 and take care of the denominator. And multiplying both sides by 2, I have 500 is equals to 7 plus 43 gives 50 times n, so 50n, or n into 50. Now obtaining n becomes easier because I'll just divide both sides by 50, and 50 goes into 500 10 times. So the value of n, which is the number of terms in this progression, is equal to 10. Now to proceed to find the common difference in that progression, I have to use the expanded form of this formula, because the last term here, or the nth term of an AP, is given by a plus n minus d. So if I expand it and plug in the nth term here, then Sn becomes n divided by 2 into 2a plus n minus 1 times d. So I have to use this formula because this introduces d, which I've been asked to look for. So I'll plug in all what I have into this formula and use it to find the value of d. Sn, the sum of the first n term, is 250, n is 10, divided by 2 into 2a, 7, 10 minus 1, 9 times d. Now at this point again, I'll multiply both sides by 2. Even though you can see divide 10 by 2 and proceed, you arrive at exactly the same answer. So 500 becomes 10 into 14 plus 9d. Dividing both sides by 10, I have 50 is equal to 14 plus 9d. And to obtain d, I have to subtract 14 from both sides, and I have 9d is equal to 50, take away 14, which is 36, and d becomes, dividing both sides by 9, d gives me 4. So the number of terms in this progression is 10, and the common difference of the terms is 4. Now let's move on to the Roman 2 part of question 4, which is a question on binomial expansion and not combination. Alright, obtain the first 4 terms of the binomial expansion. 1 minus 3 divided by 2x raised to the power negative 2, and the set of values of x for which the expansion is valid. Hence, state the first 4 terms of the binomial expansion. 2 minus 3x raised to the power negative 2. So we've been given this binomial to expand, and also state the range or the set of values for which the expansion is valid, and hence we use the answer we have had here and state the first 4 terms of this other binomial expansion. So in order to proceed, we need to write out the formula for the extended binomial expansion for negative powers. Because the power here is negative, we have to use this expansion, because this expansion is valid for negative and fractional powers. Alright, now we only have to compare the terms in this binomial expansion. The first term here is 1, and then the other term is negative 3 divided by 2x. So this big X becomes negative 3 divided by 2x. And n, which is a power, is negative 2. So I will just substitute it into this formula of the expansion, simplify, and then I'll be able to have the expansion, the first 4 terms of that expansion. So let's start off with the first term, which is 1. The second term is multiply n times x, and n is negative 2. And x is negative 3 divided by 2x. So I have negative 3 divided by 2x. I add it to, I move on to the third term, negative 2 into negative 2 minus 1. Then x squared, this is x. I square it, I divide by 2 factorial. I move on to the fourth or the last term for this particular expansion. I have negative 2 to negative 2 minus 1, negative 2 minus 2. Then x cubed, I square the whole of that x divided by 3 factorial. Now I just have to simplify and I'll be able to get my result. So the first term is just 1. Then simplifying this, I have negative 2 times negative 3 divided by 2x. Negative gives positive. So the second term is plus 3x. The third term, let me simplify everything here and expand this before multiplying. So negative 2 minus 1, negative 3 times negative 2, this is what I have here. 2 factorial is just 2 times 1, which is 2. And expanding this gives me 9 divided by 4 x squared. Then moving on to the last term, I have negative 2 into negative 3 into negative 4. Then cubing this will give me negative 27 divided by x cubed. Now simplifying, I'll have 1 plus 3x. Then this cancels out. Negative times negative is positive, and 3 times 9, 27 divided by 4x squared. Now negative 2 times negative 3 gives me positive 6, so it cancels out this way. And then negative times negative is positive. 4 goes into 8 2 times, and I'm left with positive 27 over 2x cubed. So this expansion gives us this. So this is the value of this expansion. So I've written out the first 4 terms of this binomial expansion. I hope you have understood. Now let us write the range of values for which it is valid. So this expansion that I have here is valid when this value of x lies between negative 1 or 1. That is, the absolute value of x is strictly less than 1. So I'm going to take now, since x stands for all of these terms, negative 3 divided by 2x, so the validity of this function, it is when negative 3 divided by 2x absolute value is less than 1. Then that means that negative 3 divided by 2x lies between negative 1 and 1. I can multiply both sides by 2, and I have negative 2 lies between, then I'll have that negative 2 is less than 3x is less than 2. Then dividing both sides by 3 tells me that x is between negative 2/3 and positive 2/3. So here is the validity of this expansion. I hope we are together. All right. Now the last part of the question is that we have to use the result we have here and state the first 4 terms of this expansion. So we are stating, that means we don't have a lot of work. Each time you see hence in a question, it tells you that you should use what the knowledge you have had before and apply it in order to obtain the result. There's no otherwise here, so there's no other method that we are required to use and solve here unless we use what we have had before. So we have had that this is an expansion, and we must use this expansion and state the value of this expansion. So what are we supposed to do? What we are supposed to do here is that we have to write this in the form that we can be able to use what we have ahead. So we have to factor out these 2 in order to have 1, and we'll be able to use the expansion that we had above in order to state the terms of this expansion. So let me factor out 2. Are we together? So if we factor out 2 here, I have 2 divided by 2, I'm left with 1, and negative 3x divided by 2, I have negative 3 divided by 2x. So when you factor out 2, this is what you have. And remember, the exponent is tied to the entire bracket. So that's why I've written the exponent right up, which is tied to whatever I factored from this particular binomial. All right. Now, if I multiply out the bracket, notice that I'll come back to the same thing, because 2 times 1 gives me 2, and 2 times negative 3 divided by 2, 2 strike off with 2, I have negative 3x. Now, this exponent now will distribute into the bracket. So I'll be having 2 raised to the power negative 2 into 1 minus 3 divided by 2x raised to the power negative 2. And 2 raised to the power negative 2 is 1 divided by 2 squared. Now, this is exactly the expansion that was given in the first part of the question. This is the expansion, and these are the first 4 terms of that expansion. So I'll just gather all these first 4 terms and substitute it into this. So this is what I have. So now all what I'm left to do, 1 over 2 squared gives 1 over 4. So I have to multiply each term within this bracket by 1 over 4. So I have 1 over 4 plus 3 over 4x. Then plus 27. 4 times 4 gives 16x squared plus 27. 4 times 4 gives 4 times 2 gives 8x cubed. So this is the expansion of 2 minus 3x raised to the power negative 2 based on the previous expansion that has expanded. I hope you have understood But if you do have any questions, leave it down there in the comment section below. And if you find value in this content, then please give me a like on this video, subscribe to my channel, and turn on the bell icon so that when I post videos like this one, you will be among the first persons to be notified. And if you also want to have this presentation as a handout PDF, then check the first comment section below. I will direct you on how you can have this PDF and then go through and read whenever you have the chance. All right, thank you so much for watching, and we are going to move on to the next question. Question 5 is a question on application of calculus and combination. Now, question 5, Roman 1, application of calculus. The parametric equation of a curve is given by x is equals to 1 plus t, y is equals to 2 plus 1 over t is different from 0 is a parameter. Show that an equation of the normal to the curve at the point where t is equals to 2 is 8x minus 2y minus 19 is equals to 0. Find the value of t at the point where this normal meets the curve again. So we have been given the parametric equation of a curve, and we have been asked to show that the normal to that curve at the point where t is equals to 2 is equal to this equation. And let us find the value of t at the point where the normal that we have obtained will meet with the curve again. Alright, these are the parametric equation of the curve, and we are looking for the equation of the normal to the curve, and the equation is of the form y minus y1 is equals to mn into x minus x1, where mn stands for the gradient of the normal, and then we know that mn times mt is equals to negative 1. The gradient of the normal times the gradient of the tangent is equals to negative 1. This is because the normal and the tangent are perpendicular lines, and two lines are perpendicular when the product of their gradient gives you negative 1. Alright, y1 and x1 here stands for the point where the curve and the tangent meet. That is the point where the curve and that tangent meet. Y and x are just general points in that equation. Okay, now mt is the same as the derivative of that function, the gradient function, which is given by dy by dx. And since the function or the curve was defined parametrically, we have to use our idea of parametric differentiation to obtain mt, the gradient of the tangent, by finding dy by dx, which is equal to dy by dt divided by the x by dt. Okay, now x is equals to 1 plus t, so the x by dt will be equals to 1, because finding the derivative of this function with respect to t gives 1. And then y is equals to 2 plus t raised to power negative 1, so dy by dt will just be finding the derivative of the right hand side. We have negative 1 divided by t squared. Now, so dy by dx will be equal to dy by dt, which is negative 1 divided by t squared divided by the x by dt 1, which just gives you negative 1 divided by t squared. Alright, so the gradient of the tangent at the point where t is equal to 2, I'll just substitute this t here by 2, and I'm going to be having that the gradient of the tangent is negative 1 divided by 2 squared. That gives me negative 1 divided by 4. Now I can now use the gradient of the tangent and obtain the gradient of the normal by using the equation mn times mt is equals to negative 1. So I substitute, so I have mn into negative 1 quarter is equals to negative 1. This will give me that the gradient of the normal is equals to multiplying both sides by 4, the negative strikes off, I have mn as 4. Then also, when t is equals to 2, because at the point of contact, I can have the point there, I can have the point x1 and y1. So at the point of contact, t is equals to 2, x1 will be, I'll substitute 2 here, so 1 plus 2 is 3, and y1, I'll substitute 2 here, I have 2 plus half, that gives me 5 divided by 2. Okay, now, therefore, applying this equation, I have y minus y1 is equal to mn into x minus x1 becomes y minus y1 is 5 over 2 is equal to m the gradient into x minus 3 because x1 is 3. Now, at this point, I just have to multiply out the bracket on the right-hand side. That gives 4x minus 12. I multiply both sides by 2 to take care of this denominator. 2 multiplies each term. I have 2y minus 5 is equal to 8x minus 24. Then I have now to bring all terms together on one side of the equation, because remember, this is what I have to show, that 8x minus 2y minus 19 is equal to 0. So I will bring all the terms to one side of the equation, and then I will just take all the terms to the right hand side. So I have 8x, then this 2y goes over and becomes negative 2y, negative 5 goes over and becomes positive 5. So I'm going to have negative 24 plus 5. So I'm going to have 8x minus 2y minus 19 is equal to 0 as required. So I have shown that the equation of the normal to the curve at the point where t is equal to 2 is equal to this equation. Alright, then how do we find the value of t at the point where that normal meets with the curve again? Now, if the normal meets with the curve, it means at the point of contact, the values of x and y are the same, or the values of t at that point of contact are the same. And this is the equation of the normal in terms of x, and these are the value of x, the equation of the curve. So I will just substitute in the equation of the curve into the equation of the normal and solve for the value of t. Then remember, we were told that a point of contact is when t is equal to 2. So when we solve this equation, we should have two values of t equals to 2 and t equals to the other value of t which we have been asked to look for. So let me substitute. So the curve and the line meet again when I just substitute in the equation of the curve into the equation of the normal. So I have 8 into 1 plus t minus 2 into 2 plus 1 over t, y, minus 19 equals to 0. Multiply out the bracket. I'm going to have that 8 plus 8t minus 4, negative 2 multiplies, negative 2 over t minus 19 equals to 0. Let me multiply each term by t to take care of the denominator. So I have 8t plus 8t squared minus 4t minus 2 minus 19t equals to 0. So this is only a quadratic equation. So let me rearrange all the terms on one side. So I have 8t squared, then negative 4t minus 19t plus 8t gives me negative 15t minus 2 equals to 0. So I have now to solve this quadratic equation. So I look for two numbers which multiplies to negative 16 and add to negative 15. The numbers are nothing but negative 16 and 1, because negative 16 times 1 gives negative 16, negative 16 plus 1, negative 15. So I've just split this negative 15 into two convenient numbers. So let me group the first part and factorize. 8t is common into t minus 2, and here 1 can be factored out, or just t minus 2. Then t minus 2 can be factored out again into 8t plus 1 equals to 0. Now I can use the new factor law to say that either t minus 2 is equal to 0 or 8t plus 1 equals to 0, and I'll have t as 2, the first value that was given to me. So indeed, they meet at the point where t is equal to 2, and also I'll have t as negative 1 over 8. So this is the other value of t at the point where the normal meets with the curve again. So we had our t as negative 1 over 8. So the normal meets with the curve again when t is equals to negative 1 divided by 8. So I hope you have understood, and if you do have any questions, then please leave it in the comment section below. And in the course of watching, if you find this video useful, then please don't forget to leave a like on this video, subscribe to my channel, and turn on the bell icon so that each time I post videos like this one, you'll be amongst the first persons to receive them. So, and if you also want to have this presentation as a PDF, then don't forget to check the first comment section in this video's description. Now, question 5, Roman 2 equation on combination. A new primary school intends to recruit a head teacher and 7 other teachers. There are 3 males and 2 female applicants for the position of the head teacher, 4 male and 6 female other applicants for the teaching positions. Find the number of different ways of selecting the staff of 8 if gender equity must be respected. Now, this question was a little bit challenging for most students, but we are going to break down the question together. The main keyword in this question is gender equity. Gender equity means that the number of male teachers in that school should be equal with the number of female teachers in that school. And then we also have that some 3 male and 2 female teachers, they applied for the position of the head teacher. And 4 male and 6 female teachers, they applied for teaching positions in that school. Now let's find the number of different ways of selecting a staff of 8. It means that in all the possibility, the number of male teachers must be equal with the number of female teachers because gender equity must be respected. Okay, now I'll draw a table where I'm going to put in all the information concisely. We are going to walk through this question together. Now, firstly, we can either have a head teacher and then we select male teachers from the 4 who applied for the teaching position, and we can also select female teachers from the 6 who applied for the teaching position. Now, the idea here is that if you select a head teacher, it can either be a male head teacher or a female head teacher. And if you select a male head teacher, for example, you are going to select 3 other male teachers and add to that one, and 4 other female teachers so that gender equity is respected. Or if you select a female head teacher, then you are going to select 4 male teachers and 3 other female teachers in order that gender equity is respected. Okay, let us fill the table together. Now let's suppose that you have selected a male head teacher. Now, there were 3 applications from the male teachers for the position of the head teacher. So I can select it in 3 combination one way because one head teacher is selected from the 3 males that were there. It's a male. If I select a male, I need 3 other male teachers to add it to this one, and then 4 other female teachers to have a staff of 8 where gender equity is respected. So how can I select 3 male teachers from the 4 male applicants who applied for the teaching positions? I can do that in 4 combination 3 ways. Then I go now to the section of the female teachers and I select 4 of them out of the 6 that applied, and I can do that in 6 combination 4 ways. So 1 plus 3 is 4. This is a male, and 4 and 3 other male teachers, that gives me 4. Then plus 4, that gives me 8. So this is one of the possibilities of selecting a staff of 8 where gender equity is respected. Now, suppose now that the head teacher selected is a female, and we had 2 applications for female head teacher. So I can select that in 2 combination one way. Then if I select a female head teacher, I'll need to select 4 other male teachers, which can be done in 4 combination 4 ways because we only had 4 male teachers who applied for the position of teaching. Then, since I had selected 1 female teacher, I need 3 other female teachers in order to add to the female head teacher and make it 4. And that can be done in 6 combination 3 ways. So let us add them together. 1 plus 4 gives 5 plus 3 gives 8. And out of these, I have a female and 3 other female. That gives me 4 female teachers in that school, and I have 4 male teachers. So we see that we have selected them while respecting gender equity. How then can we write this mathematically and have our result? Since the event of selecting the head teacher and the male and female teachers are independent, I will multiply out their result, and these 2 possibilities cannot occur at the same time, mutually exclusive, so I can add them up together to have my result. So the total number of ways will be I multiplied out these combinations, I add it to the product of these other possibilities. And if you do the math, you are going to have 220. I'm sure you can multiply them on your calculator. So punch them on your calculator and ensure that you have 220 possibilities or 220 ways. So a brief explanation is that the head teacher applicants, there were 3 males and 2 females. And for the teaching positions, there were 4 males and 6 females. And selecting a staff of 8 if gender equity or gender equality is respected implies that there must be 4 male and 4 females in that staff. I hope you have understood, but if you do have any question on this particular question 5, then drop them in the comment section below. I'll go through and answer them. And also, if you are watching this video and you see it important and you like what you're seeing, then I would love that you give me a like on this video, subscribe to my channel, and turn on the bell icon to receive videos like this one. And you know what to do if you want to have a PDF of this presentation as a handout. Now let's look at question 6, a question on coordinate geometry. Now this question seemed to be challenging to most students, but ironically, it is one of the easiest questions in this question paper. Now we are going to look at the question together and you'll probably see why this question wasn't as challenging as you thought. So let's look at question 6 together. The curve with the equation y is equals to 2x into 3 minus x crosses the x-axis at O and B. A. State the coordinate of the point B. A straight line which crosses the y-axis at the point E with coordinate 0, 5 meet the curve at the point C and D as shown in the diagram above or by the side. The coordinates of the point D are k, k. B. Show that k is equal to 5 divided by 2. C. Find the equation of the straight line passing through D and E. D. Show that the x-coordinate of the point C is 1. E. Calculate the area of the region R bounded by the curve y is equal to 2x into 3 minus x and the line DE. Now we have a curve, and on this figure here we have point OB, which are the x-intercept, and we have point ECD, point on this line, and the equation of the curve has been given, and also the coordinate of the point E has been given. Of course, is the y-intercept, that is why x there is 0. And we have been asked a number of questions to solve. Let us start with the first one. Now, the first question is, let's find the coordinate of B. If we look at this figure keenly, you realize that this curve cut the x-axis at the point B. So this B is on the x-axis. So B has no height. So B is called the x-intercept. And at the x-intercept, the value of y is 0. So all what we need to do is to take this equation of the curve which was given to us, substitute y with 0, and solve for the value of x. So in fact, I'll just replace y with 0, and now I'll be equating 2x to 0 and 3 minus x to 0. If I equate 2x to 0, I'll see that x is equal to 0. But I can see that B can never give me a value of x equals to 0 because there is a difference from O. B is not at O, so x cannot be 0. That is why I say x cannot be 0. So when I solve now 3 minus x equals to 0, I'll have a value of x equals to 3. So indeed, the coordinate of B is a point 3, 0 and not 0, 0, because 0 tells us that B is at O, but which is not the case. So B must be 3, 0. Alright. Question B. Let's show that K is equal to 5 divided by 2. That is what we have to show. And what is K? K is a coordinate of D. So let's show that this coordinate here is equal to 5 divided by 2. Now, how do we proceed? D is on the curve, of course. So it must satisfy the equation y is equal to 2x minus 3 minus x. 2x into 3 minus x. So D is on this curve. So it must satisfy this equation. And if the coordinates of D are k and k, it means that this k must also satisfy the equation of the curve. So that means that x is equals to k and y is equals to k at that point. So I will substitute x here with k, y with k, and solve that resulting equation. So I'll have k is equals to 2k into 3 minus k. Now at this point, you can be tempted to just divide both sides by k and proceed, but that will not be mathematically correct because you are looking for k and you cannot be dividing or cancelling both sides by the variable which you are looking for. This will just mean you are going to lose one of the solutions. So instead of dividing both sides by k, I'm going to multiply out the bracket and then bring like terms together and solve. Multiply out the bracket, 2k distribute into the bracket, 2k times 3, 6k, 2k times negative k minus 2k squared. Now let me bring all the terms to one side of the equation, and so I'll be having 2k squared, and k minus 6k gives negative 5k is equal to 0 because I'm left here with 0. Now at this point, I can factor out k as a factor, so I have 2k minus 5 is equal to 0. I can use the new factor law and say either k is 0 or 2k minus 5 is equal to 0. But k cannot be 0 because the point D is not at the origin. But if you have divided both sides by k, you will not even have that k is equal to 0. Although this 0 makes sense because the curve also passes at the point 0, but we are at D. But the coordinate here cannot be 0 because this is not at the origin. Alright, so k is equal to 5 divided by 2 because I send 5 the other way. I send 5 the other way and I divide by 2. So k gives me 5 divided by 2. So indeed, the coordinate of the point D is 5 over 2, 5 divided by 2. Alright, let us move on to the C part of the question. The C part says, find the equation of the straight line passing through the point D and E. The coordinate of E was given as 0, 5, and the coordinate of D, we have solved it and we have had it as 5 over 2, 5 divided by 2. So we can use it now and use the equation of a straight line given 2 points to find the equation of the line segment DE. We know that this is the formula for the equation of a straight line given 2 points. Y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1, where x1, y1, x2, y2 are the given points on the line, x and y are the general points on that line. So I can say E will be the point x1, y1. So x1 is 0, y1 is 5, and D will be the point x2, y2. So x2, 2 over 5, y2, 2 over 5. Let me substitute this information into the standard form of the equation of a straight line given 2 points. So I'll be having now y minus y1, which is 5, divided by x minus x1, which is 0, is equals to y2, 2 over 5, minus y1, 5, divided by x2, 5 over 2, minus x1, 0. Please, this is 5 over 2 and not 2 over 5. Okay, I will correct it. Alright, so 5 over 2 minus 5. 5 over 2 is 2.5 minus 5 should give me negative 2.5 as well. So I have negative 5 all over 2 divided by 5 over 2 minus 0 is also 5 over 2. So at this point, these two values are the same, only for the fact that this one is negative, so it will give me negative 1 when I simplify. So y minus 5 divided by x is equal to negative 1. I can just multiply both sides by x and I get y minus 5 is equal to negative x. Then I can bring all terms to one side of the equation and I get x plus y minus 5 is equal to 0, or y is equal to 5 minus x. So this is the equation of the line segment joining the point DE. I hope you have understood, but if you have any questions, I'll be reading the comment section to find out your difficulty in these solutions. Okay, let's move on now to the point. So I've had the equation of this line. So I have the equation of this line ED. In fact, the entire line, I have the equation. I also have the equation of the curve, which is y is equal to 2x into 3 minus x. Now the next question now reads, show that the x coordinate of the point C is equals to 1. All right, the s coordinate of this point C is equals to 1. So what is C? C is a point of intersection of the line and the curve. That means at the point C, both the x coordinate of the line and the x coordinate of the curve are the same, as well as the y coordinate of the line and the y coordinate of the curve are the same. So I can just equate the equation of the line to the equation of the curve and then find the value of x. So the line and the curve intersect at 2 points, C and D. Hence, y1 is equal to y2 at these points. So at the point of intersection, because the line and the curve intersect at these points, that means the value of x and y are the same. But I'm concerned only with the x coordinate of C. So I will solve for that equation when I've equated them to find the value of x. So let's solve together. So this is the curve and this is the line. I've equated them because we saw previously that the curve, the equation of the curve is 2x into 3 minus x, and the equation of the line is y is equal to 5 minus x. So I'll just equate this equation of the curve to this equation of the line, because this is the y coordinate, this is the expression or the equation of the curve, and this is the equation of the line, and this is the equation of the line. I equate them and I'll be having this. So I just have to manipulate, use my knowledge of algebra and find the value of x. Multiply out the bracket, I get 6x minus 2x squared is equal to 5 minus x squared. This is a quadratic equation, so I bring like terms together. Let me take this negative term to the other side. I get positive 2x squared, then negative x minus 6, negative 7x, then positive 5 plus 5 equals to 0. I can just split this middle term and I factorize them. Two numbers which multiplies to 10 and add to negative 7. The numbers, of course, are negative 5 and negative 2. So negative 7x can be replaced with negative 5x minus 2x. So let me group these two terms and factorize. X is common into 2x minus 5. Negative 1 is common into 2x minus 5. So 2x minus 5 again is common. I factor out 8, and I have x minus 1 into 2x minus 5 equals to 0. Let me apply the new factor law and find the value of x. Either x minus 1 is equals to 0, which will give me x equals to 1, or 2x minus 5 equals to 0, which will give me x as 5 divided by 2. Now I have two values of x, so I have to eliminate one of them. So I have that x is equals to 1 and x equals to 5 all over 2. We see that the line and the curve meet at 2 points, and I have two values of x. So I see that x, the coordinate of C cannot be 5 over 2 because the coordinate of D is already what? 5 over 2. So it must be less than 5 over 2, which is 1. So I can now eliminate x as 5 over 2 and conclude that the coordinate or the x coordinate of the point C is equal to 1. So I've shown that the s coordinate of the point C is equal to 1. I've shown it. Now the last question is to calculate the area of the region R bounded by the curve y is equal to 2x into 3 minus x and the line DE. So I'm looking for the area R. Now how do we find the area R? So to find the area under a curve, we have to use the idea of integration. But then we have to integrate at the point of intersection. I have the point C and the point D. So I'm looking for the area from the point C to the point D. That is the x coordinate of C to the s coordinate of D. Now at this point, I'll realize that the curve is on top and the line is below. So the formula for the area will now become that the area will be the integral from A to B, because A to B, from integral from A to B, yes, from A to B, so I would have said from C to B, from A to B of y upper minus y lower. So I will take the upper function at that point of intersection minus the lower function at that point of intersection with respect to x, where y upper will be the function, the equation of the curve, and y lower will be the equation of the line. Because we have had the equation of the curve, if you multiply, you have 6x minus 2x squared, and the equation of the line is simply x minus 5. So it's simply 5 minus x. So this is what we have. Alright, so at this point, I'll just plug in the values. Then I'm going to simplify and integrate from their point of intersection, because they intersect from the point C to the point D. So let me plug them in. So I'll have 6x minus 2x squared minus y lower, or the function beneath, 5 minus x. So let me just multiply the bracket and bring terms together, like terms together. I have 6x minus 2x squared minus 5x plus x. So this simplifies to 7x minus 2x squared minus 5. So I integrate each of these arm from 1 to 5 over 2. Why is it from 1 to 5 over 2? Because at this point of intersection, the coordinate of C is 1 and that of D is 5 over 2. So the x coordinate of C is 1 and the x coordinate of D is 5 divided by 2, because I'm integrating with respect to x. So when I integrate 7x, I just have 7x squared divided by 2. When I integrate negative 2x squared, I have negative 2x cubed divided by 3. When I integrate negative 5x, I have negative 5x, of course from 1 to 5 over 2. Now let me plug in the limit, or I'll plug in the upper limit and subtract the lower limit. So when I plug in the upper limit and I subtract it like so and simplify all this, notice that here I'll substitute 5 over 2 everywhere else I see x, and subtract from, I substitute 1 everywhere I see x. So I subtract this lower limit from the upper limit, and evaluating this using your calculators or whatever method, you are going to have the area as 9 all over 8 square units. Now I must emphasize that you must not necessarily say y upper minus y lower. You can just subtract them. But if you solve and your result is negative, it means that you have to find the absolute value of that result. So if I were solving and I instead took the equation of the line minus the equation of the curve, I will have the same answer but with an opposite sign, negative. So I have to find the absolute value of that result to have the same result I have here. So just know that you have to subtract the equation of the curves, integrate it within the limit, and then if it's negative, find the absolute value, and if it's positive, then your subtraction was right. I hope you have understood. So if you do have any questions, leave it in the comment section below, and if you find value in this content that I am presenting, then you know what to do. Just give me a thumbs up, then subscribe to my channel, turn on the bell icon to receive videos like this one each time I post it. And you can also check the first comment below to see how you can get this presentation as a handout PDF. Thanks for watching, and we are going to move on to question 7. Now we are with question 7, complex numbers and vectors. Question 7, Roman 1, complex numbers. A complex number z satisfies the equation z divided by z plus 2 is equal to 2 minus I. Express z in the form a plus bi, where a and b are real constants. Now we have z divided by z plus 2 is equal to 2 minus I. So we have to make z the subject in this particular equation. We have to transpose this equation and make z the subject. Now, one of the ways by which we can go by is by multiplying both sides by this denominator. So multiplying both sides will give me z is equals to z plus 2 into 2 minus I. Now let me multiply out the bracket by expanding, and I have z is equals to z times 2, 2z, z times negative I, negative zi, 2 times 2, positive 4, 2 times negative I, negative 2. Now let me take all the terms in z to the left hand side, and I'll be having z minus 2z, and I add positive zi because this cosine becomes plus zi is equal to 4 minus 2i. Now 1z minus 2z is negative z plus zi is equal to 4 minus 2i. Then let me factor out z from these two terms. Z is factored out, and I have I minus 1 is equal to 4 minus 2i. Then let me divide both sides by I minus 1, and I get z is equal to 4 minus 2i divided by I minus 1. Now, in order to solve this, we were asked to give our answers in the form a plus bi, and this does not have a complex denominator. So let me explain some things here. This is a complex number. It has two parts, the real part A and the imaginary part B. B is called the imaginary part because it's attached to an imaginary concept I, or an imaginary number I. Now, in order to solve this problem, we need to find the conjugate of this complex number. A complex conjugate of a plus bi is a minus bi. So to find the complex conjugate of a complex number, you change the sign on the imaginary part. So here, the complex conjugate of I minus 1 becomes negative I minus 1 because the imaginary part here is negative 1. So I'll then multiply both sides, the top and the bottom, by the complex conjugate of the bottom. Notice that I haven't changed the value of z because this cancels out to give me 1. But then let me multiply and see what I will get. Let me start with the top. 4 times negative I, negative 4i, 4 times negative 1, negative 1. Negative 2i times negative 1. Now, negative 2 times negative 1 gives me positive 2. I times I squared, and I squared is equals to negative 1. So that is why I have negative 2. Now, negative 2i times negative I gives positive 2i divided by, I'm now multiplying a complex number by its conjugate. So let's multiply together. I times negative I will give me negative I squared, and I squared is negative 1. Negative 1 times negative 1 gives positive 1. All right. So I times negative 1, negative I, negative 1 times negative I, positive I. So those two terms cancel out. I'm left now with one term, which is negative 1 times negative 1, that gives 1. So for short, when you are given a complex number and its conjugate to multiply, your result is always the sum of the square of the real and imaginary part. So I square the imaginary part, 1 squared gives 1. I square the real part, negative 1 squared gives 1, and I sum them. So simplifying, negative 4i plus 2i gives me negative 2i. Negative 4 minus 2 minus 6 divided by 2. 2 is common to these both terms, and 2 strike off and give me negative I minus 3. So this is a complex number z. I hope we are together. Alright, let's move on now to 7 Roman 2, the question on vectors. The vector equation of two lines are given by r is 3i plus 6j plus k plus lambda into 2i plus 3j minus k. And r, the other line, is 3i minus j plus 4k plus mu into I minus 2j plus k. A. Find the vector normal to the plane containing both lines. B. Obtain the Cartesian equation of the plane containing both lines. So this is the first equation of the plane, 3i plus 6j plus k plus lambda into 2i plus 3j minus k. And this is the vector equation of the second line. Now we have been asked now to find the vector normal to the plane containing both lines. So the vector normal to the plane, n, is obtained by finding the cross product of the direction vectors of those lines. So in this vector equation of a line, we have two parts. This first part is the position vector of the line, is the position vector of the line, while this second part, which is multiplied by a parameter, is the direction vector of the line. So to obtain the vector normal to the plane, we have to find the cross product of their direction vector. So I will in fact be finding the cross product of this vector and this other vector down here. So what I'm saying is that n, which is the normal vector to the plane, is given by a cos b, where a is the direction vector of the first line and b is the direction vector of the second line. So I have n is equal to a cos b is equal to, now in order to find the cross product of two vectors, we proceed in the same way as we find the determinant of a 3 by 3 matrix. So I have I, j, k to be the component of those vectors, and now I write out their coefficients beneath. So 2, 3, -1, and here I have 1, -2, 1. So I have to find the cross product of these vectors. Let's proceed together. I have I multiplied by the minor determinant. So I cross out the column and I cross out the row, and I'm left with a 2 by 2 matrix, which is 3, -1, -2, 1. Minus j, the term in j is always negative. Minus j multiplied by its minor determinant, which is obtained by crossing out the column and the row, and I'm left with the matrix 2, -1, 1, 1. Then plus k, I cross out its column and the row, I have 2, 3, 1, -2. Now, how do we find the determinant of a 2 by 2 matrix? By finding the product of the elements of the leading diagonal minus the product of the elements of the non-leading diagonal. So I into 3 times 1 is 3, minus -2 times -1 is 2. Minus j into 2 times 1 is 2, minus 1 times -1, -1. So 2 minus -1 gives 2 plus 1. Then finally, 2 times 2 is -4, minus 1 times 3, -3. So doing the math and evaluating, simplifying, I'll have I minus 3j minus 7k. So this is a vector normal to the plane. Alright, the B part is to obtain the Cartesian equation of the plane containing both lines. So to obtain the Cartesian equation of the plane containing both lines, we use the formula r dot n is equal to a dot n, where r is the general point on the plane, a is any point on both lines, so a can be either this position vector or the position vector of the second line. And n, of course, is the normal to the plane, which we just obtained. So let us go by this formula and evaluate it. So r is the general point x, y, z, dot n is the normal to the plane. So I write out their coefficients, and I'm going to write it out in the column form. You are free to write it in the vector form, and I'll advise you to always write it in the column form when you're multiplying, because it is more convenient to multiply it this way than when it is in the vector form. So it's equals to a dot n. A is any position vector. You can either take the first or the second. So in this case, I have taken the second, which is 3, -1, 4. Those are the coefficients of I, j, and k. Then dot n. Our n, of course, is 1, -3, -7. So I find the dot product of these vectors. X times 1 is x, y times -3 is -3y, z times -7, -7z is equals to 3 times 1 is 3, -1 times -3 is +3, 4 times -7 is -28. Simplifying the left hand side, I get 6 minus 28, that is -22. So the Cartesian equation of the plane is x minus 3y minus 7z is equals to -22. I hope you have understood the solution. But if you do have any questions, the comment section is open for you. If you do find value in this content, then give me a like on this video, subscribe to my channel, and turn on the bell icon so that you receive notifications about upcoming videos. And you know what to do if you want to have this presentation as a handout, as a PDF handout, so that you can easily navigate through. Thank you so much for your kind attention, and we are moving on to question 8. Now, we are now on question 8, circles and location of roots. Now, question 8, Roman 1. The equation of a line is 3y is equals to x plus 5, and the equation of a circle is x squared plus y squared minus 6x minus 2y minus 15 equals to 0. Show that a segment of the line is a chord to the circle. Now, this question has been corrected. In the question paper, there was probably a typing error, and there were 2 equal signs here, which made it impossible to interpret the question. So I've corrected the question so that the idea of the question will be maintained, and I'll be able to show you how to solve this particular question. Now, we have been given a circle and we have been given a line. How can you show that a line is a chord to a circle? What is a chord? In order to know what a chord is, let us understand what a tangent is first. A tangent is a line that touches a curve or a circle at just one point. That is a tangent. So a tangent just touches the circle at one point. But a chord is another line that touches the circle at two different points. That means it cuts the circle at one point and another point. It passes through the circle. For example, a diameter is a chord because it touches the circle at 2 points on the circumference. Now, in order to show that this line is a chord, we have to show that this line touches the circle at two different points. So we have the equation of the circle, we have the equation of the line as 3y is equal to x plus 5, and we have the equation of the circle as x squared plus y squared minus 6x minus 2y minus 15 equals to 0. Let me call this equation 1 and equation 2. The equation has been corrected. Now, to show that a segment of a line is a chord to a circle, we are required to show that the line cuts the circle at two different points. This can be shown by solving these equations simultaneously. Now, I'll solve them simultaneously. So that means I'll take in the equation of the circle of the line and plug it into the circle and solve it. Okay, let us make x the subject in the equation of the line. Making x the subject, x will be 3y minus 5. So I will come to the equation of the circle, and anywhere I see x, I will replace it by the value of x here, which is 3y minus 5. So I'll have 3y minus 5 all that squared plus y squared minus 6 into 3y minus 5 minus 2y minus 15 equals to 0. Now I have to multiply out the bracket. When I expand this first term, assuming that you can expand it, I'm going to have 9y squared minus 30y plus 25 plus y squared. And when I also expand every other thing, this is what I have. Now, let me bring like terms together. And when I simplify everything here, simplify and confirm this, you are going to have 10y squared minus 50y plus 40 equals to 0. We can simplify this equation further by dividing each term by 10. Dividing each term by 10, I have y squared minus 5y plus 4 equals to 0. Alright, I will stop here and explain some concept. We have been asked to show that the segment of the line is a chord. To show, we were not asked to find the coordinate where the chord cuts the circle. So to show, we only have to show that if you solve this quadratic equation, you are going to have two different answers, two different values for y, which tells us that the line indeed cut the circle at two distinct points. And mathematically, how can we show that this quadratic equation has two distinct roots? By showing that the discriminant of this equation is greater than 0. So the discriminant is given by b squared minus 4ac. b is negative 5 minus 4, a is 1, and c is 4. That gives us 9. This means if we solve this equation, we are going to have two different answers for y. So this one is already okay for us to confirm that because the discriminant is positive, it tells us that there are two different values of y. Therefore, the line segment is indeed a chord because it touches the circle at two different points. But if you were asked to find the coordinate where it cuts, now you need to solve for the value of y, then substitute it into any of these equations and find the corresponding value of x. And those will be the coordinates of the point of intersection. I hope you are with me here. Alright, but if you don't understand and have a question, you know what to do. Go down there in the comment section. So already at this point, so the equation has two distinct roots. Hence, the line is a chord to the curve. So that question is answered. Now let's go to question 8, Roman 2, a question that has to do with location of roots. The question reads, show that the equation x squared minus 3x plus 1 equals to 0 has roots between x equals to 2 and x equals to 3. Taking x equals to 3 as a first approximation to this root, use the Newton-Raphson method to obtain a second approximation to the root. Now, we have been given the function, let me call that f of x is equals to x squared minus 3x plus 1. And we have been asked to show that the root of this equation lies between 2 and 3. The easiest way to show that is to use the intermediate value theorem. If f of x equals to 0 has a root between 2 and 3, it tells us that if I substitute negative 2 into this expression and substitute 3 into this expression and multiply that value, then the result should be negative. So this is the condition to show that the root lies between two values. Of course, because the curve is cutting the x-axis, and so it's either living from positive to negative or from negative to positive. So that means there must be a change in sign. So the product of those values should give you negative. So essentially what I have to do here literally is to obtain f of 2 and obtain f of 3 and show that they have opposite signs, because the product of numbers with opposite sign must be negative. So let me start with finding f of 2. F of 2 means I just substitute 2 into this function. So I have 2 squared minus 3 into 2 plus 1. That gives me 4 minus 6 plus 1, which is negative 1. And f of 3 is I just substitute it into this function, just as I've done here, and it gives me 1. Now notice that they have opposite signs. Even at this point, you can conclude that since f of 2 have opposite signs to f of 3, then the root lies between 2 and 3. But we can simply just multiply by saying that since negative 1 times 1 is less than 0 because it's negative, it implies that f of x has root between 2 and 3. So you have shown that the root of this equation indeed lies between 2 and 3. Now, the subsequent question is that let us use the Newton-Raphson's method to obtain a second approximation to the root by taking x equals to 3 as the first approximation. Alright, now this is the Newton-Raphson's method of approximation of root. So I've called that initial approximation x0, which is equals to 3, and I have to look for the second approximation, which is x1. So x1, this is a formula. It states that x1, or the subsequent root, is equal to the previous root x0 minus f of x0 divided by f prime of x0. So I need to find the derivative of that function as well. So what is f of x0? I just substitute 3 into that function. I did that already and it gives me 1. So what is f prime of x? F prime of x means I differentiate this function, which gives me 2x minus 3. So f prime of x0, I will then substitute 3 into the function f prime, and that will give me 2 into 3 minus 3, 6 minus 3, that gives me 3. So I'll just come back to this formula, plug in the values, and evaluate to obtain a second approximation, x1. So x1 will be 3 minus f0, which is 1 divided by 3. Doing the maths will give us 8 over 3, and that is approximately equals to 2.667. So this is the second approximation of the root using the Newton-Raphson's method of approximation. I hope you have understood, but if you do have any questions, then leave it in the comment section below. And if you find value in this content or in this presentation, then give this video a thumbs up, subscribe to my channel, and turn on the bell icon. Thank you. And if you also want to have this presentation as a PDF, you know what to do. Check the first comment in the comment section below. Thanks for your kind attention, and let's move on to question 9. Alright, question 9, calculus. Question 9, Roman 1. Solve the differential equation x dy by dx is equals to y into y plus 1, given that y is equals to 4 when x is equals to 2, and express the solution in the form y is equals to f of x. Now we have been given a differential equation, and we have been given the values of y and the value of x, and we are asked to solve this differential equation expressing it in the form y equals to f of x. In other words, let's make y the subject when we have solved this differential equation. Alright, with that being said, let's copy out the question, and what we can do here is to separate our variables. Separating the variable means I'm going to manipulate this equation and write the terms in y on one side of the equation and the terms in x on the other side of the equation. Now, there are many ways to do that, but for me, I find it easier to start by finding the reciprocal of both terms across the equation. So if I find the reciprocal on the left hand side, I get the x divided by x dy. The reciprocal of the right hand side, I have 1 divided by y into y plus 1. Now at this point, I have to take the terms in y on the right hand side and leave the term in x on the left hand side. So if I multiply both sides by dy will strike off from the right hand side and then will strike off from the left hand side and then come to the right hand side. So I'll be having dx over x is equals to dy divided by y into y plus 1. Now at this point, notice that I've separated my variables, because on the left hand side I can only see terms in x, and on the right hand side I can only see terms in y. So at this point now, I have to integrate. But then before I integrate, I need to realize that the right hand side can be decomposed into partial fraction, because I can split the denominator into two separate fractions. Okay, how do I go by splitting the denominator? Since the denominator is linear, we are going to split it in the same way as we did for question 1. So I can write this as a divided by y plus b divided by y plus 1. Then I will find the value of a and b, and if I find those values, then I must have decomposed this into partial fraction. Now I'll use the cover up method because again, the bottom is linear, and that method is easier and convenient when the denominator is linear. So how do I find a? To find a, the critical value of y is just 0. Then I will cover up y and substitute everywhere else I see y here with 0. So using the cover up method, a will be equals to, the critical value here is 0, so I cover up this term y, and I replace everywhere else with 0. So I have 1 divided by 0 plus 1. So a is equals to 1. What about b? To obtain b, I have to find the critical value of y plus 1. The critical value of y plus 1. And the critical value of y plus 1 is simply negative 1. Because y plus 1 equals to 0 will give you y as negative 1. So I come back here, I cover up y plus 1, and I replace everywhere I see y with negative 1. So b will be equals to 1 divided by negative 1. Evaluating that gives me negative 1. So I have the value of a and b. So I've decomposed this into the sum or difference of its partial fraction. So I'll have that. Let me integrate both sides. The integral of 1 over x with respect to x is equal to the integral of a is 1 over y minus 1 over y plus 1 with respect to x, because b, of course, is negative 1. And integrating this becomes very easy, because if I differentiate the denominator and I have exactly the numerator, then the result is the natural logarithm of the denominator. So I had to put a dx here. I had forgotten, but it's okay because you understand. I hope so. So the integral of 1 over x with respect to x will give me ln x. And if I integrate this one as well, when I differentiate y with respect to y, I have 1. So the integral of 1 over y will give me ln y. Then when I differentiate y plus 1, I also have 1. So I have negative ln y plus 1 plus a constant a. Now I need to find the value of this constant using these initial values that were given to me in the question. Now I have been told that y is 4 when x is 2. So I'll replace y by 4 and x. I'll replace y by 4 and x by 2 and then find the constant a. So I'll be having that, but before I do that, I need to simplify further, because I have that I'm subtracting this natural logarithm and I need to apply the laws of log. I know that log A minus log B is the same as log A divided by B. So I can apply the laws of log to these two terms and I obtain ln of y divided by y plus 1, then plus A. Then let me plug in the limit as I was explaining, and I'll be having ln 2, because x is 2, is equals to 4 ln 4 divided by 4 plus 1, 5, plus a constant A. Now let me make A the subject of the formula, and making A the subject of the formula, I will now just take the other terms to the other side of the equation. So A becomes ln 2 minus ln 4 over 5. I can see apply the laws of logarithm here, which should be 2 divided by 4 over 5. So A is ln 2 divided by 4 over 5. And doing the maths of what I have in bracket, I have ln 5 all over 2. So A is ln 5 all over 2. So now ln x becomes ln y divided by y plus 1 plus ln 5 divided by 2. Remember, I have to make y the subject of this equation. So what am I supposed to do here? I'm supposed to make y the subject of the formula. So I am going now to bring terms together. So I'll have ln x is equals to ln y divided by y plus 1 plus ln y divided by 2. So at this point, let me make ln y divided by y plus 1 the subject of the formula. So I subtract ln 5 over 2 from both sides. So I'll be having ln x minus ln 5 over 2. Then I'll apply the law of logarithm once more to the right hand side. And I'll be having ln x divided by 5 all over 2. And x divided by 5 over 2 gives me 2x divided by 5, because the terms will reciprocate. So at this point, I can take natural logarithm of both sides, because the inverse of ln is e. We actually have to eliminate the ln in order to make y the subject. So taking e of both sides, I'll just have y divided by y plus 1 is equals to 2x divided by 5. Then cross multiplying, I have y plus 1 plus 2x gives 2xy plus 2x is equals to y times 5, that gives 5y. Then I can just factor out, I can bring terms in y together. I have 2xy minus 5y is equal to negative 2x. Let me factor out y from these two terms, and I get y into 2x minus 5 is equals to negative 2x. Finally, dividing both sides by 2 minus x gives me y is equals to negative 2x divided by 2 minus x, or I can bring down this negative sign and it distributes amongst the denominator and gives me now positive 5 minus 2x. I hope we are together, but if you do have a question, a doubt, or anything disturbing you, then leave it in the comment section of this video and just indicate the question number that you have difficulties in. I will come and intervene by answering your question. All right. Okay, question 9, Roman 2. Using a suitable substitution, show that the integral from 0 to 2 of x times the square root of 1 plus x squared with respect to x is 1/3 into 5 root 5 minus 1. So we have been asked to use a suitable substitution. This is because maybe this integral is a little bit cumbersome, and now we need to reduce it by using substitutions. Now, if I look at this integral, I'll realize that this term here makes the integral cumbersome. So I'm going to substitute this term with a variable. Now, I can decide that I will let u to be 1 plus x squared, so that I'll be having now the square root of u, which makes the integral a little bit simpler. And now that we have chosen a variable as u, we also need to change the integration variable from x to u, as well as the integration limit. But I can even go a step further by letting 1 plus x squared to be u squared, so that the square root of u squared will just give me u, and it will be simpler than even what I explained before. So I'm going to move on, and I'm going to let u squared to be 1 plus x squared. Now let me start by changing the integration limit from x to u. Now when x is 0, because the lower limit is 0, I replace here by 0, u squared will be 1, and the square root of both sides gives u as 1. Let's take the positive value. Now that x now, the upper limit is 2, I replace here by 2, 2 squared is 4 plus 1, 5, and the square root of 5 gives root 5. So now I've changed the limit from x to u, which is 1 to root 5. Now let me go ahead also and change the integration variable from the x to the u by differentiating this expression implicitly. Now let us move on. When I differentiate u squared with respect to u, I have 2u du by dx. When I differentiate 1 plus x squared with respect to x, I have 2x. Now 2 can cancel out from both sides, and I make the x the subject of the formula, so the x will just be equals to u du divided by x. Now let me plug in everything else into this integration and then proceed to evaluate it. Now, so the integral will be the integral now from 1 to 5, the new limit, times x multiplied by the square root of, I let everything inside here to be u squared, times the x, and the x is u du divided by x. This x cancels out very nicely with this x. Then the square root of u squared gives me u, and u times u gives me u squared. So everything here simplifies now to just the square root from 1 to root 5 of u squared with respect to u. Now when I integrate u squared, I add 1 to the power and I divide by the new power. So I'll be having u cubed on 3 from 1 to root 5. Let me now plug in the limit, and I'll have that the upper limit will be root 5 all that cubed divided by 3 minus 1/3. Now 1/3 is common to these two terms. I can factor out 1/3. Then, and root 5 cubed is root 5 times root 5 times root 5. That gives me 5 times root 5. Then minus 1 as required. So I have shown that this integral is equals to 1/3 into 5 root 5 minus 1. I hope you have understood, and if you find value in this content, in this presentation, you know what to do. Please give me a thumbs up, subscribe to my channel, and ding the notification bell icon. You can also share this video to your friends, to those who you think this video will be useful to them. And you know what to do if you want to get this presentation as a PDF. Just check the first comment section below. Now let's go now to the last question, question 10, trigonometry and complex numbers. 10 Roman 1, find the values of r and alpha where r is positive and alpha is an angle between 0 degrees and 90 degrees, for which 4 cos theta plus 3 sin theta is equivalent to r cos theta minus alpha. Hence, obtain the greatest value of the expression 1 divided by 4 cos theta plus 3 sin theta plus 6, and give the corresponding value of theta between 0 degrees and 360 degrees. So let's start off with the first question. We have been told that r is a positive number and alpha is an acute angle. Now, and we are asked to express 4 cos 3 plus 4 cos theta plus 3 sin theta in the form r cos theta minus alpha. Now, what we have to do is that we have to expand this compound identity on the right hand side. And I think this expansion is in your formula booklet. So if you do the expansion, you are going to have cos theta, cos alpha, you add, so this sign changed now to positive, sin theta, sin alpha. Now let me multiply the bracket. That means r will distribute itself. Then I will equate corresponding coefficients of cos theta and sin theta and solve for the value of r and alpha. Now, equating corresponding coefficients of cos theta and sin theta, we are going to have that. Now, if we expand, we are going to have r cos theta cos alpha, then plus r sin theta sin alpha. Then the coefficient of cos theta on the left hand side is 4, while the coefficient of cos theta on the right hand side is r cos alpha. The coefficient of sin theta on the left hand side is 3, while the coefficient of sin theta of the right hand side is r sin alpha. So I equate them and I'll be having that r cos alpha is 4 and r sin alpha is 3. So I'm left now to solve these two equations to obtain values of r and alpha. Now to obtain alpha, is really easy because if I divide equation 2 by equation 1, I'll be having tan alpha. So dividing equation 2 by equation 1, r cancels r, sine divided by cos gives tan, so I have tan alpha is equal to 3 divided by 4. So alpha is just the tan inverse of 3 divided by 4, which gives me 36.87 degrees to 2 decimal places. Now the next thing to do now is to find the value of r. R is easily obtained because if I square equation 1 and I add it to the square of equation 2, then I'll have that r squared is equal to 4 squared plus 3 squared. So for short, anytime that you are solving this problem, r is obtained by just squaring each of these arms, adding them, and finding the square root. So r will be equal to 4 squared plus 3 squared, which is 16 plus 9, which is 25, and the square root of 25 gives me 5. You could still take alpha as 36.87, plug it into any other equation and solve for r. But in that case, your r will not be exact as this value because you are going to approximate and round off your numbers, but it will be very close to 5, but not exactly equal to 5. So this method gives you an exact value for r. I hope that is understood. Now, with that being said, that means that 4 cos theta plus 3 sin theta is equal to 5 because r is 5, cos theta minus alpha 36.87 degrees. Now, the next question is that let us find the maximum value that this function can take. And remember that 4 cos theta plus 3 sin theta is f of theta that we just expressed. So let me call this f of theta. So I can write this one now as 1 divided by f of theta plus 6. So I'm finding the maximum value of this function. But then we know that f of theta is equals to this function 4 cos theta plus 3 sin theta, which has been expressed as 5 cos theta minus 36.87 degrees. And when you express the sum into a factor like this, it becomes very easy to bound the function. Bounding means that you can write the function between two values, which it will never be below that value or above that value. Like for example, cos theta and sin theta are bounded functions. The maximum value that cos theta can take is 1, and the minimum is -1. And that is the same for sin theta. So cos theta is bounded between -1 and 1. And if cos of any angle, if the cosine of any angle is bounded between two values, which is +1 and -1, it means that 5 cos theta minus 36.87 degrees will be bounded between -5 and +5 because you have multiplied that -1 or +1 by 5. I hope we are together. Okay, so how can we find the maximum value of this fraction? Now the idea, I've called it a fraction for a reason, because we know that when the denominator of a fraction is reducing, the value of that fraction increases. And when the denominator of the fraction is increasing, the value of that fraction decreases. So in order to have the maximum value of this fraction, then I need to divide it by the smallest or the minimum value of in the denominator. Because I can bound the function f of theta, that means I can write f of theta between two values, which is maximum and minimum. So what I have to do here is that I need now to find the minimum value of f of theta and substitute it here, and now this fraction or this value will now be maximum. Now let us go ahead now and bound f of theta between the two boundary values. Now we know that f of theta, which is cos theta minus 36.87 degrees times 5, is bounded between -5 and 5. So the maximum value that this function can ever take is 5, and the minimum value that it can ever take is what? -5. Since I'm looking for the maximum value, I need to place the minimum value in the denominator. And therefore, to bound that function, I will now be having that the maximum value will be 1 divided by the minimum value of f of x, which is -5 plus 6. Evaluating, 6 minus 5 is 1. 1 divided by 1 gives us 1. So the maximum value of that expression is equals to positive 1. Now that we have that the maximum value is positive 1, the next question was that let us find the corresponding values for which that maximum value occurs between 0 and 360 degrees. So I need to come back to this question now. And now, since the maximum value is 1, I can rewrite the whole expression and I equate it to 1 because that's the maximum value. And I find the value of theta for which that maximum value occurs. So I can cross multiply, and this multiply with 1 and gives me the same thing is equals to 1. I subtract 6 from both sides and it gives me negative 5 on the right hand side. I divide both sides by 5. Then I have cos theta minus 36.87 degrees is equals to negative 1. Now at this point, I can find cos inverse of both sides because cos inverse of negative 1 is 180 degrees. So theta now will be equal to 180 degrees. This negative 36.87 crosses over to become 36.87. 36.87. I add it to 180, and when I do the addition, it gives me 216.87 degrees. So you can punch this to confirm. Okay, let's just punch that on our calculators and see if you are going to have that same value. Are we together? So let's take my calculator. Let me start by finding cos inverse of negative 1. So let me press shift, cos inverse of negative 1. So what is the result? The result is 180 degrees. Then this term cos becomes positive. So let me add it to 36.87. So 36.87 degrees. That gives me a fraction. So let me press this and change from the standard form to decimal. That gives me 216.87. So indeed we are correct. So let's go back to that presentation. So we have 216.87 degrees. Now what you need to take note is that I just need to stress on that fact that anytime that you are solving this type of problems and you have these two equations, to obtain R, you just square these arms, these numbers this way, add them and find the square root. So R is just equals to the square root of A squared plus B squared. So take note of that. Now let's go to the very last question, question 10, Roman 2. Use the Moivre theorem. Write down the equivalent form of cos 3 theta plus I sin 3 theta. Hence, show that sin 3 theta is equivalent to 3 sin theta minus 4 sin cube theta. Alright, so let us write the equivalent form of this using the Moivre theorem. So we know that Z is equal, so if Z is equal to cos theta plus I sin theta, then Z cube using the Moivre theorem will give you cos 3 theta plus I sin 3 theta. This helps us to raise a complex number to a power. So we are multiplying the angle by that power to have this. Okay, so we have applied the Moivre theorem to raise Z to a power of 3. See, similarly, in the same way, we can also find Z cube by expanding this. So this is R. We can also find Z cube by, this is Z. We can also find Z cube by expanding this. So what is Z cube? Z cube will be the expansion of cos theta plus I sin theta, all that cube. But we can use the binomial theorem to expand this so that we will not waste a lot of time. We know that A plus B, all that cube, using the Pascal triangle or any other expansion method that you can think of, will be A cube plus 3A squared B plus 3AB squared plus B cube. So this is the expansion of A plus B, all that cube. Verify it, try it, and confirm that this is indeed the expansion. Alright, let us now use this expansion and expand Z cube, not R cube. So I'll be having, this is A and this is B. So what am I going to have? A and this is B. So I'll be having cos cube theta, because that is A, plus 3 cos squared, so A squared, cos squared theta multiplied by B, which is just I sin theta, plus 3 AB squared. A is cos theta, I sin theta all that squared. Finally, I add b cube, which is I sine theta all that cube. Now let me expand it. Expanding this and simplifying, I'll just have cos cube theta. Then I'll have 3 cos square theta sine theta I. So this part is imaginary. Then when I expand this, I have to multiply out the bracket. I squared gives me -1. So this term becomes real. So I'll be having minus 3 cos theta sine squared theta. And when I cube this, I times I, -1, times I will give me -I, minus sine cube theta times I. But then notice that sine 3 theta from this expression is the imaginary part, of this complex number. So this complex number has two parts, the real part and the imaginary part. Sine 3 theta, what I've been asked to look for, is the imaginary part of this expansion. So I have to take this expansion now, and now I equate it to sine 3 theta in order to solve it. So, but sine 3 theta is the imaginary part of z cube, as we have seen before. So that means sine 3 theta is equal to imaginary part of this expansion. So sine 3 theta is equal to, this is the imaginary part. So this and this. So I'll have 3 cos square theta sine theta minus sine cube theta. When they say imaginary part, we can just take just the value and allow the I, because the I is what let us know that it is imaginary. Because the reason why we know that sine 3 theta is imaginary, because it is attached to I. So I'll just say sine 3 theta is equal to 3 cos square theta sine theta minus sine cube theta. Now I just have to simplify all of this and show that this should give me the expression that I have to show. So in this expression, I don't have any cos. So what I have to do is to change all the cosine to the sine. And that would be writing cos square theta as 1 minus sine square theta. Then let me expand. This 3 will distribute. I have 3 minus 3 sine square theta into sine theta minus sine cube theta. Let me distribute it again. I have 3 sine theta minus 3 sine cube theta minus sine cube theta. Then then I can just rewrite this other one because these are like terms, and I'll be having 3 sine theta minus 4 of sine cube theta, and which is exactly what I was asked to show. Now, congratulations for arriving at the end of this presentation. Well done and congratulations. So I hope you have understood the concept that you had to apply during this examination. So I have just done what I can for you to understand. So what you can do to repay me back is just to place some comment that is going to motivate me to produce videos like this one. And you can also share these videos to those whom you think this video will be useful to them. And also, we have come to the end of the presentation for now. But before we go, you have to take note that the Moivre's theorem states that if z is r cos theta plus I sin theta, then z raised power n is equal to rn cos n theta plus I sin n theta. We applied it here in order to resolve this problem. Now, we are going to stop here, but before we go, if you have any questions, then leave it in the comment section below. And if you have some recommendations for future videos, some challenges that you have, then you can also leave it in the comment section below. And if there are some corrections or some positive criticisms that you think that I can do to improve on the quality of my videos, write down below. I am somebody who loves to be criticized in order to step up and do something better. And finally, your comments will be very important. So if you see that this video has helped you a lot, then you can drop positive comments in the comment section to motivate me to produce videos like this one in the future. And thank you so much for watching. Thank you so much for your patience, and you all have a wonderful day.